Today I'm going to continue the theme of last seminar, and we are going to solve some simple problem from elementary geometry. And main subject of our lesson is triangles, are triangles. First of all, I recall a simple proposition which give condition for equality to various triangles. First condition: if you have two triangles, maybe A, B, C, and A prime, B prime, C prime, and the side of first triangle and two adjacent angles are equal to the corresponding side and to adjacent angle of another triangle, then these triangles are equal. The second condition of equalities: if we have also two triangles and the angle and two adjacent sides of first triangle are equal to corresponding angle and two adjacent sides of another triangle, then these two triangles are equal. Maybe BAC is equal B prime A prime C prime. AC is equal A prime C prime, and AB is equal A prime B prime. Then and third condition is follows: if all sides of one triangle are equal three sides of another triangle, then this triangle are equal. More precisely speaking, these triangles are congruent, but with naive point of view, we can tell that these triangles are equal. Let's start for this a simple problem, simple exercise. Exercise 1. On the side AB of a triangle ABC, we take a point D and on the side A prime B prime of a triangle A prime B prime C prime, we take a point D prime. Given that the triangles ABC and A prime D prime C prime are equal, and the segments D, B and D prime B prime are equal. Proof. That proof that the triangles ABC and A prime B prime C prime are equal. A we have that the triangles ADC is equal A prime D prime C prime, and segments DB is equal D prime B prime, and these triangles are equal. And then we have the equalities of these triangles. We can use these properties, and based on these properties we will try to prove this proposition. Mm-hmm. Uh-huh. Wait. Population. Okay, let's discuss the last previous problem. Yes. Okay, let's start to solve the new problem. Can you prove the equality of these triangles? Can you try? Yeah. Oh, maybe write down on the desk. Can we have that two triangles are equal, and we use what properties of this? Yeah, segment. Okay, yeah. And we have also this. Yeah, and this is equal this. This is equal this. And what about this angle? Can we assert this that these angles are equal? Why? Yes. Why? Yeah, it's complementary of these angles. And okay, and we can use the property 2. The property 2, and we have these two angles. These two triangles are equals, and then this side is equal this side, and that's all. We use the third property and obtain proof this problem. All right. Okay. Yeah. Oh, okay. Sun Wan Gao, you are right. Yes. And about angle, okay, yes, and yes. This angle, this angles are equal, and then this also equal. And after them we use property 2 and after property 3. It's a simple exercise. More exactly, we can see that is maybe only example of how to apply these properties to solve such simple problem. Okay, let's to solve following problem. Maybe okay, the a second exercise. Prove the following. Case of triangle equality triangle. Two triangles are equal if they have an equal angle equal bisector issued from this angle. And equal side adjacent to this angle. So side equal sides. Equal side adjacent to this angle. We have angle ABC is equal to the angle A prime, B prime, C prime. Bisectors BD and, for example, the sides AB and A prime, B prime are equal. And then let's prove that and these triangles ABC and A prime, B prime, C prime are equal. We can sometime. Yeah, it's similar.
A, B, B equals F prime, B prime, D prime.
Yes, yes. This angle, these triangles are equals, yes.
And the surface of the bisector is equal, and the adjacent side is equal, and the angle between them is also
Okay.
equal. So we have equal triangles.
These triangles?
Yes.
Yes. And this? Yes, yes. Okay,
So
it's right.
The angle A equals angle A prime.
Yeah.
And we have already B.
Yeah. exactly. Okay. Yes, it's a simple exercise. Okay. Let's continue, and maybe a little more hard problem. Three. Let's prove that a triangle is isosceles. A, if an bisector is also altitude. First exercise B. If a median is also altitude, and third exercise, if an angle bisector is also a median. First of all, let's prove item A. We have some triangle A, B, C, and bisector B, B prime, B, B prime is bisector and is an altitude. Let's prove AB is equal BC. Okay. Let's try to prove, for example, that the triangles ABB prime and CB prime B are equal. And from this easy follows that these sides are equal. No? What means altitude? Altitude is perpendicular. Okay, and then we have this prime and this this common side, and we can apply the property 1, yes, property 1, and after them easy to obtain the proof of these items. B. If median is also altitude. Median, and we have AB prime here, side, and what mean future? More hard. Maybe continues this. And there are A, B, B prime, C. Maybe D. Maybe D. B prime equal B prime D. This angle. Let's compare this angle and this angle. Symmetrically continuous. This angle is equal. These sides are equal. And then this triangle and this triangle are equal. Let's compare this triangle and this triangle. This angle are equal. This angle equal this and equal this. This angle also equal and this angle also equal. These sides also equal. And we have that this triangle equals this triangle. And compare, we obtain that this triangle and this triangle are equal. More hard, but we can imagine and continue this picture, and we see the quality of this triangles. And last proposition: if an angle bisector is also, I'm sorry, I prove the third assertion is most hard, and median is also altitude. It's more simple. Let's try to prove. Median and altitude. Altitude means perpendicular this side. It's very simple assertion. It's evident. Common side is equal, this angle are equal. One step using property property 2. Using property 2, we obtain the proof of this item 2. Okay, and let's continue. And maybe a little more hard, exercise 4. We have angle on side OX of some angle. We take two segments length OA and OB, and on the side OX prime we take segments of the same length. Such that OA is equal OA prime, OB is equal OB prime. We draw AB prime and A prime B, which cross each other. In the point I. The point I. Show that point I lies on the bisector. Bisector of the given angle. Bisector. try to use this condition. Maybe compare some triangles on this figure, this draw. Mm-hmm. Mm-hmm.
And B prime A are diagonals of the shape
Mm-hmm.
and B prime B.
Mm-hmm.
What the intersection would be that.
Mm-hmm. Let's point the equal segments. This, 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 this also equal. Let's continue this, maybe with these triangles and these triangles. These triangles have the common angle, and this side equals this side, and this side is equal this side. And here that this triangle equal, yes. That's right. And we can write down that triangle B O R prime is equal B O R prime is equal B prime O A, and this segment equals this segment. Okay. Mm-hmm. And this angle equals this angle. This angle equals this angle. Oi, no. This and this angle. No, and this also equals this. Mm-hmm. This equal this triangle equals this triangle. This side is equal to this side. And we can compare these two triangles. This angle I equal, these angles I equal, and then these angles also equal. We win. Okay. It's a little more hard problem. And let's continue. And exercise 5. More interesting problem, in my opinion. Points M and N are given. Given the points M and M, and these points lie inside some acute angle. Acute angle. How to direct a ray of light from point M so that it reflected sequentially from the sides of this angle, reaches point N. N we have two way such trace for this light ray. Maybe so, and maybe so. How to understand, how to construct this trace for the ray? We use these properties that if race is trace race, this angle is equal to this angle. The most important property for the moving ray. How to use this property and draw this way of the light ray. We have initial point M and end point N all this way. we want to choose some point P so that angle PM is equal angle the angle MPX is equal angle OPM. How to choose this point so that this condition is fulfilled? How? I don't understand. How to choose P? Can we use some construction for this point so we by natural way to obtain this condition? Let's try to use some symmetry condition on this draw. Symmetry condition, maybe. The main idea on for this sorts of problem is to use some symmetry. Let's try to reflect point AM onto axis OX. And introduce, imagine point M prime. We have symmetry for these points. And suggest, imagine that ray move from M prime to N. It's the shortest way. And we can see that two angles are equal, but we have symmetric picture, and follows from this symmetry we have also quality this angle and this angle, and we have equalities of two angles. And this answer on the question. And how to use this construction and construct other way for ray light. And we also reflected for this other side, and we can also in this point. But we have more hard questions. The ray must reflect it of both sides. And let's try to solve this more complex problem. We have some idea for this. To use some properties of symmetry, and can we use this property such to construct this more complex way for ray light, ray of light. Question? symmetric to n onto other x or y or x prime. And let's use 2 points for defining the way of this right. Okay. No, it's not simple. And okay, we have only point m and m prime and n prime, and let's understand how to move the ray so that reflected sequentially from the both sides to reach point n. The claim for light for ray is to move so that moving from m prime to n prime, the shortest way. I assert this, that the right answer is let's show that this angle I equal this angle and this angle equal this angle. It's easy task. This angle equals this angle equals this angle, then this side is equals this, and we have some answer for this question. It's right way for ray of light. It's a simple problem, but enough important, and we will use this reasoning. The main idea is some symmetry of this picture, and we use some principle for moving ray. The qualities of some angles for trace of ray. And the main principle, the way of ray, is shortest. Is have shortest length, and this principle is consequence of this main principle, the physical principle, member-theory principle, maybe it's called. Okay, it's enough interesting problem, and the following property is more simple. This problem is more simple. We repeat the following proposition. We use the following proposition. If we have triangle, the sum of all angles of triangle is equal 180 degrees. And on the last lecture, we prove this assertion. We have some simple corollaries for this assertion. For example, we have a convex, maybe polygon with 5 sides. The question: how to calculate the sum of this angle in this case? A simple exercise. Let's choose some point in the interior of this polygon and construct these triangles. Let's note that we have 5 triangles. The sum of angles of each of these triangles is 180 degrees, and sum is equal 5 multiply 180 degrees is equal 900 degrees. But sum of these interior angles with one common vertex is equal 300. And the sum is a difference between this value and this value. And we have 900 degrees minus, and it's a general formula for n polygon, and we have exactly general answer. For when n is equal to 5, we obtain such formula. That is true in the general case. Okay, but this formula can be applied to the convex polygon. But in some questions, we have deal with non-convex. For example, let's we have some star. Can you calculate the sum of this angle in the star? You can try to calculate the sum. And maybe we can to generalize this calculation on the case of n-corner stars, like this. This sum can be calculated by the various ways. For example, we can use such construction like and calculate the general sum by the sum of this and obtain this sum. Let's try. I can write down the answer. Answer is very simple in this case. Maybe this is homework. exactly calculate in this case this sum, and maybe we can obtain some generalization of this situation on the n-corner star and obtain some analogues of this general form of it's useful task. And maybe I have more interesting problem, and we try to apply some knowledge we have on the last lectures, on the second sem of last lecture, geometrical inequalities. And I recall the main inequalities, triangle inequalities, or equivalent inequalities for triangles, sum of two sides of triangles greater than third side, length of third side. And exercise 7, proof that the sum of the three medians of a triangle is less than the perimeter but more than three divided 4 of the triangle's perimeter. We have the triangle. Three medians A, B, C, MA, MB, MC. First item, the sum MA plus MB plus MC less than A plus B plus C, and MA plus MB plus MC greater Let's try to solve this problem. Can you solve? No? Can we prove some assertion? Maybe lemma. I assert that median A and B less than the sum A plus C. Can you? Oh, I'm sorry. Two lengths of A and B greater than less than A plus C. This assertion. Try to prove this. No. No, maybe we can use some symmetry and let's some we can construct some symmetrical triangle which is equal given triangles B. Okay. Let B prime such point that AB prime parallel BC, B prime C is parallel IB, and this side is equal to this side. This triangle AB prime C is equal to triangle ABC, and B prime is equal to MB, and AB prime is equal to BC. But in the triangle AB prime, sum of lengths of sides AB and AB prime greater than length of BB prime. But length of BB prime is to length of median MB. AB is equal C and AB strich is equal AC and equal A. And using triangle axiom or geometrical inequalities, which was above formulated, we can conclude that 2MB less than sum A plus C. And we just obtain the solution of this problem. We can repeat this reasoning for other sides and other medians, and we obtain that to another inequalities. And adding these inequalities, we obtain the answer, solution of this problem. Okay. Do you understand it? Yes, it's I have 5 minutes only, or less. I'm not sure. Have 5. Okay. Yes, we have 5 minutes, and I try formulate maybe the following problem. I have 2 problems, and I would like to recall the Tifagorian theorem. If we have right angle triangle, and theorem asserts that square of so-called hypotenuse is equal sum of squares of 2 other sides, which called legs. For example, if A is equal 4, B is equal 3, C is equal 5, yes. Yes. Maybe we try the sum problem. We have such triangle. This angle 30 degree, this angle 45 degree. Is this side is equal to let's try to find length of other sides. This angle is equal 105. Yeah, 105. Okay, we have maybe 2-3 minutes, and we can to try suggest the plan of solution, maybe idea of the solution. I'm not sure that we can to solve this problem, but we can say formulate maybe main idea of solution. Let's you can draw altitude in this triangle. Let point C prime is point of intersection with altitude with side AB. And we also that this angle is equal the right angle 45. Yes. This angle 45. And this angle, yes, there is 60 degrees here. And we can some properties. This side is equal to these sides. These sides is half of these sides. And these sides is sum of this and this. And we can to try express these sides one another. And we obtain some equalities, and to solve it we obtain the answer of this problem. Let's try homework. Thank you. I am finished. And some home task problem. The home task will be given in the end of this month on elementary geometry. I choose some problem for this and send maybe 5, and we can send me the solutions of this problem in during maybe 1 to half. That's all. Thank you.